Okay, so next we're going to move on to trig functions with derivatives. So how to find the instantaneous rate of change using a trig function. So let's just slide down a little bit here. I'm actually going to skip to this part here. We're going to look at how do you find the derivative of certain trig functions. And a lot of this is memorization, mostly. And the good news is you won't really have to memorize since you'll have your notes at all times. So really it's just application at this point. So derivative of sine is cosine. The derivative of cosine x is negative sine x. Derivative of tan x is secant squared x. Derivative of cosecant x is negative cosecant x cotan x. Derivative of secant x is secant x tan x. And the derivative of cotan x equals negative cosecant squared x. Now, first thing you'll notice is some tricks that people use to help memorize these. Well, I highlighted all the ones here. Why did I highlight these three? Well, it's cosine, cosecant, and cotan. They all are they all start with C. And anything that starts with C, this is something I used to use, has a negative in front. So cosine x, negative sine x. Cosecant, negative cosecant cotan. Cotan x, negative cosecant squared. Okay? Now, for example, derivative of tan x equals secant squared x, you could get there. For example, here. Let's take a look at how this comes up. So it says determine the derivative of tan x using the quotient rule. Well, how would I use the quotient rule? Well, let's rewrite tan x as sine x over cosine x. And now we would use the quotient rule. Remember the quotient rule says low d high minus high d low over low squared. So let's see how that would work. We would get y prime equals low times the derivative of the top. The derivative of sine x is cos x minus high times the derivative of cosine x is negative sine x all over the low squared, which is cosine squared x. Well, now what happens in the numerator? You get cosine x times cosine x is cosine squared x. Sine x times negative sine x is negative sine x squared times a negative. Distribute it, you get minus sine squared x, plus sine squared x, a negative times a negative, over cosine squared x. Well, how does that help us? Well, if you remember the trig identity, cosine squared x plus sine squared x is just 1. 1 over cosine squared is equivalent to secant squared x. So you see these derivatives do originate from different methods. You could come up with them, but it's easier just to memorize them. All right, just to save time, let's skip here. So let's do some practice. Now the thing about trig derivatives is that they apply the chain rule. So the chain rule, if you remember, was derivative of the outside times derivative of the inside. And we're also going to use some trig manipulation to help us out. When you have cosine squared x, this could be rewritten, guys, and it's just going to make it easier as cosine x squared. And if you see that, then you will see that it does look like the chain rule. So f prime of x, right? Derivative of the outside, so 2. Sorry, I don't want that parenthesis there. 2 cos x to the first, but we don't need to put the first. Drop the exponent by 1. Times, well, what's the derivative of cosine x? If you want to go back up and look, it's negative sine x. I'm going to put a parenthesis there because it looks weird. So, just final answer, and you don't need to rewrite it like this. It just makes it look a little nicer. You have a negative times a positive, so it's negative 2 cos x sine x. What about cosecant 5x? Okay, well, cosecant 5x, still kind of like the derivative of the outside, derivative of the inside. So first, what is the derivative of cosecant? Well, let's go back up and look. Derivative of cosecant. Negative cosecant x cotan x. The only difference is it's not x now, it's 5x. And that's fine. So we're going to put, I'll put in parentheses, negative cosecant 5x cotan 5x times, what is the derivative of the inside, 5x? Well, that's just times 5. So if you wanted to rewrite this, you could put negative 5 cosecant 5x cotan 5x, but this is fine. All right, let's take a look at another one. F of x equals cotan x squared. What's the derivative of cotan? Let's go back and see. Negative cosecant squared x. So f prime of x, negative cosecant squared of x squared. It's not x anymore, it's x squared. And now what is the derivative of x squared? Times 2x. How could you rewrite this? Well, we could bring that 2x out front, and you would probably see a multiple choice written this way. The negative stays, the 2x brings out front, and we put our trig term last. Cosecant squared x squared. Sine, parentheses, x cubed minus 5. What is the derivative of sine? We go back if you need. Derivative of sine is cosine. So, cosine x cubed minus 5 times the derivative of x cubed minus 5, 3x squared, the constant we don't need. If you want to rewrite it, that's 3x squared cos x cubed minus 5. Okay, so these are straightforward single monomial terms. Just find the derivative using our new rules. However, what if we get to something like this? X squared times sine x. Well, it's multiplication, so this is going to have to be product rule. So what was the product rule again? Well, it's 1d2 plus 2d1. Right? So if this is the first and this is the second, now we follow the product rule and we should be able to get this. Let's see. So f prime of x. Let's see. All right, first up, 1 times the derivative of the second. Well, the derivative of sine x is cos x. And you don't need to do the inside because it's just x. Plus 2, which is sine x, times the derivative of the first. Well, what was the derivative of the first? That was 2x. Okay. Now, do we leave it like this? Do we have to move anything? No, you could just leave it like that. If you wanted to, you could write x squared cos x plus 2x sine x. We like to write the trig functions last, but same thing. Okay, so now we have tan and we have quotient rule. Well, let's take a look. What is the derivative of tan? Well, it's not really quotient rule in the problem, it's quotient rule within the inside. So first we're going to look at what is the derivative of tan. Let's go back and look. Secant squared x. So derivative of this function, let's see, f prime of x, secant squared of the inside. But then we have to find the derivative of the inside. So what is the derivative of x over x plus 1? And this is the part right here we have to do the quotient rule for, okay? And the quotient rule again, low d high minus high d low over low squared. And we're going to do that for what's inside. So let's do that. So it's secant squared of the inside times, and now we have to do quotient rule out here. And it's going to get a little scary. Let's see. Well, let's say this is high, this is low. So low times the derivative of the high part, the derivative of x is just 1, minus high Derivative of the low part is just 1 over low, the whole thing squared. Now, this, I mean, you could simplify this, just x plus 1 minus x. The x's go away and you get 1 over, just leave it, it's fine. This is not a problem, that's good. Okay. Now, what about substituting in? And this is going to go back to actually some stuff that you haven't seen in a while, and you might not be happy about it, but we're going to go back to our special right triangles here. Okay? So let's see. It says find f prime of pi over 8 if f of theta equals cosine 2 theta. Well, if f of theta equals cosine 2 theta, that means, let's see, f prime of theta, what's the derivative of cosine? It's negative sine 2 theta times, what's the derivative of, theta is just a variable, think of it as, so what's the derivative of 2 theta? It's just 2. So I'm going to rewrite this actually. Negative 2 sine 2 theta. Okay. Now, let's substitute in. Then what is f prime of pi over 8? Well, that is negative 2 sine of 2 pi over 8. I just plugged in pi over 8 for theta. And 2 over 1 times pi over 8 is 2 pi over 8. Well, this simplifies. What's 2 pi over 8? That's negative 2 sine of pi over 4. Well, what was sine of pi over 4? Well, we're actually going to have to go figure that out. Pi over 4, remember, if you convert that, 180 divided by 4, or think of pi cut into force. If you cut into force, that's 45 degrees. So really this is saying find f prime of 45 degrees, which that's what we're at now. We get, let's see, negative 2 times sine of 45 degrees. Sine of 45 degrees, quadrant 1, positive. What does the 45 degree triangle look like? 45, 45, 90, 1, 1, rad 2. So what is sine of 45? It doesn't matter which one you pick. Sine is opposite over hypotenuse, 1 over rad 2. Which you could rationalize, and you get rad 2 over rad 4, which is rad 2 over 2. So now we get negative 2 times rad 2 over 2, which is negative 2 rad 2 over 2. Which, I mean, I guess you could leave it like that, but if it were multiple choice, they'd probably simplify, and you probably get negative rad 2. So what is the slope of the tangent line of this function at 45 degrees? Or at pi over 8? Sorry, at pi over 8, which is not 45 degrees. Negative rad 2. Okay, so now next up, find the equation of the tangent, of the line tangent to y equals sine 6x at x equals pi over 3. So remember, for this we need a point and the slope of the tangent line. So we need to plug in both pi over 3 into the original and into the derivative. And it doesn't matter which one you do first, it's really up to you. We could find the point first. So what is, let's say, y equals sine of 6 times pi over 3, which is sine of 6 pi over 3, which is sine of 2 pi. Well, if you remember what sine of 2 pi is, 2 pi is, well, let's see, that's 1 pi, that's 2 pi. It's a quadrantal, right? What is sine at this point? Well, what's the coordinate of this point? It is 1, 0, and it's cosine, sine. So sine of 2 pi, 0. So this is actually 0. Right? So when you plug in pi over 3 into the original, you get 0. Okay? So our point is going to be, when you plug in pi over 3, you get 0. Now what about slope? For slope, we need to take the derivative of y equals sine. Let's see, so y prime is going to be, derivative of sine is cosine 6x times the derivative of the inside, 6. So you get 6 cosine 6x. Now we have to plug in pi over 3 to that. Let's see. So y prime of pi over 3, 6 cosine of 6 times pi over 3, which is 2 pi. 6 times cosine of 2 pi. Well, what's cosine of 2 pi? Well, good thing is we already drew the picture here. Cosine of 2 pi, which is 1 full revolution, is 1, right? Because the quadrantal, the value is 1. So that's 6 times 1, 6. So you get your slope, 6. So what is the now equation of the tangent line of y equals sine 6x at x equals pi over 3? Well, it's point slope formula. It's y opposite sine, it doesn't matter because it's 0, y minus 0 equals slope 6 parentheses x minus the opposite sign pi over 3. Okay, try out the homework too. You can complete the lesson from my notes, and then that'll be it for today.